So the funnest application of Pascal's triangle permutations and combinations is to actually expand binomials that are a little bit more exciting than x plus y to the fifth. So the patterns all continue that we know. Row number, Pascal's triangle, combination form. We've had an opportunity to explore that in some of the relationships. But we can apply it in general to any binomial expansion. And we can write any binomial expansion without foiling it out, which is kind of nice. So we've done that in our previous lesson, being able to figure out x plus y relationships and Pascal's triangle and the expansion that's related to that. So using either Pascal's triangle blown up or the choice, the combination communication. But let's see the general form of what it looks like. So in general, I can expand any binomial x plus y to the n following this lovely binomial theorem rule. Now it's the counting from zero that kind of makes things problematic. Remember, you always end up with one more term than the exponent. So I get n plus 1 terms when I expand x plus y to the n. And there's actually on our formula sheet a nice summary of this binomial theorem. I can figure out what any term is in the expansion of the binomial by addressing t at the k plus 1. Remember, the k is associated with the number of choices I've made for my y, or my second term. So this formula is on our formula sheet, which is awesome. So I can use that off of our formula sheet. But I do have to remember some things about Pascal's triangle, and I'll try to demonstrate that in the first 2 or 3 examples. What is the fifth term? Where is the middle term? So I want to at least understand how that fifth term gets created and where that middle term is, and it's easier to do when the numbers are small. So the fifth term would be 1, 2, 3, 4, 5. I need 5 terms. And this is 8, choose 0. This is how I would figure it out. And then I'd choose 1, 2, 3, 4. So my fifth term would be the result of 8, choose 4. And then I would have x to the 8 minus 4 and y to the 4. So now on my calculator, I have to go 8, choose 4, 8 math, choose 4, and that's 70. And the nice thing about this binomial is I simply have x to the 4, y to the 4th. It's nothing complicated at this point. Where would the middle term of a plus b to the 10 be? Well, I first have to understand that a plus b has 11 terms. 1, 2, 3, 4, 5, 6. So by the time I get to the sixth term, there would be 5 terms before it and 5 terms after it. So now counting like I did before, this would be 10, choose 0, and then 1 choice, 2 choice, 3 choices, 4 choices, 5 choices. So I'm looking at my 10, choose 5. 10, choose 5, that would be x, which is now a, x, a to the 5, and b to the 5. So again on my calculator, 10, choose 5, 10 math, over to probability, number 3, 5. That's 252. A to the 5, B to the 5. Again, my A and B expansion isn't very exciting. I don't have numbers to worry about. I can use binomial theorem to write the expansion of x plus y to the 7. We've done that quite a bit just to get you started on that. It would be 7, choose 1, 7, choose 0, pardon me, x to the 7, y to the 0, plus 7, choose 1, x to the 6, y to the 1, plus 7, choose 2, x to the 5, y to the 2 plus. You can see the pattern. The y variables increase, and they increase by the r in your combination statement, and the x values decrease. Well, it gets a little bit more exciting if I try to FOIL out something bigger. Let's check it out. So Susan was looking at the expansion of 2x minus 5 to the 6th, and she found her x to the 3 coefficient. Well, where would the x to the 3 coefficient have arisen? The x to the 3 coefficient would have arisen when you have your k value as 3. Your k value is 3, that's the coefficient associated with your y. The x coefficient would have been 3 as well, and that's why 6 minus 3 works there. My y is -5 and my x is 2. And now I can do the work for her to figure out first what 6 choose 3 is. So 6 choose 3, 6 math, 3 is 20. And then I've got 2 to the 3. 2 to the power of 3 is 8. So it's 20 times 8 times x to the 3 times -5 to the 3. Make sure you put that -5 in brackets. -5 to the 3. Maybe you'll recognize that as -125. And then I get to multiply all those numbers together. -125 times 8 times 20 is -20,000, which is what she had come up with, x to the 3. The problems do get a little bit more interesting than this. Let's turn the page over. Okay, so maybe not relying so much on the formula, but you're welcome to check the formula out. I'm looking for the 5th term. So the 5th term would have been, I would have written it out a little bit of the choices for my coefficients. 0, 1, 2, 3, 4. Because I start at 0, remember the 5th term actually occurs when r is 4. So I've got 7 possibilities. I have to choose 4. It defines what my exponent is on the x term and what my exponent is on the y term. And now I get to go through the math. I'm going to do that and then show you the results. So 7 choose 4 is 35, and then the 3 gets an exponent 3 applied to it. I get x to the 3, I get a 2 with an exponent 4, and a y with a 4. So that continues to simplify. 35 times 27 times 16. Bring all those coefficients to the front. X to the 3, y to the 4. So final answer, 15,120, x to the 3, y to the 4. Now see if we can use our formula and a quite brutal binomial. I have x squared plus a to the 8. What's that going to look like when I FOIL it out? First of all, I know I'm going to get 9 terms if I were to expand it all out. And the largest exponent is going to be x to the 16. And that x to the 16 will drop by powers of 2. So I'll have x to the 16, x to the 14, x to the 12, x to the 10. So trying out our formula, I'm looking for a term that's based on our formula, term k plus 1. And I know how that formula plays out. The coefficient on a is my k. The coefficient on x squared is 8 minus k. And I know that when I simplify that, I'm looking for the place where I get x to the 4. So 16 minus 2k, the exponent, must be equal to 4. That means 12 is equal to 2k. That means k is equal to 6. And I'm looking for the 7th term. Now, what would the value of the 7th term be? So I can evaluate my formula, 8 choose 6. x squared to the squared times a to the 6. But apparently the coefficient is 114,000. Well, how is that possible? Well, that must be because of what a is. So 28 times a to the 6 must be equal to 114,688. And we can figure out what a is. We got to remember that a is greater than 0. That was stated earlier. So I'm going to take 114,688 and divide by 28 first. That's 4,096. And now I need to take the 6th root of that. Different ways of doing that. I'm going to go 6 math, number 5, and then enter 4,096. That'll give me the 4th root, and that'll give me a is 4. Now it is possible that a could have been -4, but since a is larger than 0, the only answer I want is a is 4. So I'm looking for the numerical coefficient of the term that has a to the 7 in it. Well, a to the 7 is actually a negative value, so I'm going to track that negative value there. So negative a to the 7 times 3 to the 3 working backwards, and 10 choose 7. So 10 choose 7, 10 math, 7 is 120 times 3 cubed, which is 27. Now I've got a -1 to the 7 and an a to the 7. So 120 times -27 essentially is -3240 a to the 7. Now this last example can provide an interesting method for problem solving. I'm looking for the constant term, but my value of x and y is really weird. I don't have a straight up x and y. What I do notice is that eventually I have to multiply 2x by some power and 1 over x squared. Actually, I'm just going to focus on the x's because the x's have to cancel. So x times 1 over x squared, eventually the x's have to cancel because I need a constant term, no x's. So x times 1 over x squared eventually has to be equal to 1. Well, how does that work in terms of our selection process, in terms of our x's? This is how I'd like to view it. So the exponent on my second term will be k, and the exponent on my first term will be 15 minus k. And I need to simplify that. I've got an x squared in the bottom, which is just awkward. So I've got x to the 15 minus k times x to the minus 2 to the k is equal to 1. That's x to the 15 minus k times x to the minus 2k is equal to 1. Well, in order for that statement to be true, I must have x to the 0 to be equal to 1. That means that 15 minus k plus minus 2k has to be equal to 0. That's 15 minus 3k is equal to 0. That's k is equal to 5. Hopefully you can see that the x's cancel. I generate an x to the 10 in the numerator and an x to the 10 in the denominator. 2 to the 10 is 1024. -1 to the 5 is -1. This all goes away eventually, and I have my 3003. So 1024 times 3003 times -1 is a really large number, -3075072. That's it for Math 30. All of our lessons are presented, and we get to set ourselves up for permutations and combinations this week. Have fun.